video, we'll be focusing on qualitative analysis. Now, what is qualitative analysis? It is the process of identifying unknown substances in a solution. At O levels, students are required to describe the use of aqueous sodium hydroxide and aqueous ammonia to identify different ions, such as aluminium, ammonium, calcium, copper 2 ions, iron 2 and iron 3 ions, lead 2 ions, and zinc ions. In this video, we are going to focus on the use of aqueous ammonia to identify these ions. For easy memory, you may divide the cations into two different groups. One group, precipitate, will form with aqueous ammonia. The other group, precipitate, will not form with aqueous ammonia. So let's say we add aqueous ammonia into this solution to test for the cations and no precipitate is formed, then we can confirm that that particular cation must be calcium ion. Calcium ion do not form precipitate with aqueous ammonia. So now, why is there no precipitate when aqueous ammonia is added to the aqueous solution containing calcium ions? Aqueous ammonia is actually a weak alkali, so it partially ionizes in aqueous solution to form low concentration of hydroxide ions. Now we know that calcium hydroxide is sparingly soluble, meaning it is soluble but not so soluble. So let's say if the concentration of hydroxide ions is low, then calcium hydroxide will remain soluble. Hence, no precipitate will be observed. Now the rest of the ions that we are concerned with, they all will form precipitate with aqueous ammonia. So some of them, they form white precipitate, and the others actually form colored precipitate with this same alkali. For white precipitate, the cations that form white precipitate with aqueous ammonia are aluminium, zinc, and lead 2 ions. For easy memory, I will advise students to remember it as Z, zinc, aluminium, and lead 2. So these three ions will form white precipitate with aqueous ammonia. So if we add aqueous ammonia into this unknown solution and white precipitate is formed, then which cation must be present? Could it be zinc? Could it be aluminium? Or could it be lead 2? So what we can do is we can further add more aqueous ammonia to observe the changes. If the precipitate dissolves in excess aqueous ammonia to give a colorless solution, then we can confirm that the ion present must be zinc ion. If we add aqueous ammonia in excess and there's no observable change to the white precipitate, then we can say that the white precipitate does not dissolve in excess aqueous ammonia. If that's the case, the two possible ions that are present must be aluminium or lead 2. So let's look at the other category, okay, colored precipitate. Now things get easier with colored precipitate because the color of the precipitate is unique to the particular cation. So let's say we add this aqueous ammonia into the solution and blue precipitate is formed. If that's the case, we can confirm that a copper 2 ion is present. Now this light blue precipitate will dissolve in excess aqueous ammonia to give a deep blue solution. Now if iron 2 ion is present in the unknown solution, if we add aqueous ammonia, then green precipitate will form. Now take note, this green precipitate is insoluble in excess aqueous ammonia. If iron 3 ion is present in the unknown solution, then what you should observe is reddish brown precipitate. Now this reddish brown precipitate will not dissolve in excess aqueous ammonia. For this particular outcome where precipitate is formed, the precipitate that you observe in each of these reactions is actually the hydroxide of the metal ion. So let's say this unknown solution contains iron 2 chloride, and these iron 2 ions react with the hydroxide ions that is present in aqueous ammonia. So the precipitate that we observe is actually iron 2 hydroxide, which is insoluble in water. Take another example. Let's say this unknown solution contains lead 2 nitrate, and then we add in aqueous ammonia. The lead 2 ions and the hydroxide ions in aqueous ammonia will come together to form a hydroxide that is insoluble in water, and hence you will see this white precipitate form. So let's back to the white precipitate, aluminium and lead 2. So we actually mentioned that aluminium and lead-2 ions, they actually give the same results if we add aqueous ammonia into the unknown solution. So for both ions, white precipitate will form, and this white precipitate is insoluble in excess aqueous ammonia. So if that's the case, what can we do to distinguish lead-2 ions from aluminium ions? Take a moment to think about it. Now, have you thought of a method? Now, there are two ways that you can distinguish lead-2 ions from aluminium ions. Now, the first way, you can actually add salt solutions that contain iodide ions. For example, potassium iodide. So what will happen is, if the unknown solution contains lead-2 ions, then you will see yellow precipitate form if you add in potassium iodide into the solution. The yellow precipitate is lead-2 iodide, which is yellow color. Alternatively, a more common method, we can add any solution that contains chloride or sulfate ions. For example, we can add sodium chloride solution, or not, we can add potassium sulfate solution. When any of this solution is added, and if we see white precipitate form, then we can confirm that lead-2 ions must be present. Aluminium ions do not form precipitate with chloride or sulfate ions because aluminium chloride and aluminium sulfate, they are both soluble in water. Now, we actually learned this solubility rule when we dealt with salts in an earlier chapter. Let's recap on this. You may want to refer to this table to have a very quick recap. So at O levels, the salts that we are concerned with are carbonate salts, nitrate salts, chloride salts, and sulfate salts. The two salts that we are focusing on now are chloride salts and sulfate salts. So all chlorides are soluble except lead-2 chloride and silver chloride. You can remember it as called little sailor, which is ClX. Chlorides that are insoluble are lead-2 chloride and silver chloride. What about sulfates? Now all sulfate salts are soluble except the following three: calcium sulfate, lead-2 sulfate, and barium sulfate. Now an easy way to remember is C, cute little baby, S, C, Lb. Now S will be sulfate. Sulfate salts that are insoluble are calcium sulfate, lead-2 sulfate, and barium sulfate. So now to distinguish aluminium ion from lead-2 ions, we are actually making use of this solubility rule. Okay, so we add any solution that contains sulfate ions or chloride ions, only lead-2 ions will form precipitate with chloride and sulfates. If white precipitate is formed, then we can confirm that the cation that is present in this unknown solution must be lead-2 ions. If there's no precipitate formed, if we add any solution that contains sulfate ions or chloride ions, then we can confirm that, hey, the cation that is present must be aluminium ions. If you find this video useful, please subscribe to the channel and like the video. Don't forget to share the video with your friends. If you'd like to have more chemistry resources, you may check out my website. The link is in the description below. Have fun learning chemistry, and I will see you soon.